Okay, here's a video that's going to go over some product and quotient rule problems along with the simplification of that type of problem. So the first one we're going to look at is this one, y equals 8, and that says the cube root of x sine of x, which is really a product of three factors, the 8, the cube root of x, and the sine of x. But 8, since it's multiplied by the whole thing, we can consider a constant multiple, and we have a theorem, a rule that says we can ignore that. So that's what we're going to do. You can kind of lump it together with the x, the cube root of x. That's not the most efficient way to do it, but it will work. So as I said, I'm going to think of it like this: 8 times the cube root of x times sine of x, and I'm going to do the product rule just on this part of it because the 8 is my constant multiple. So now I'm ready for the derivative using the product rule. So we have the first times the derivative of the second. The derivative sine is cosine, plus the second sine of x times the derivative of the first, which is 1/3 x to the negative 2/3. That is the derivative. We're done with the derivative. That was the easy part. The harder part comes with the algebra part, the simplification. Before I simplify things, I like to clean everything up. And what I mean there is there's two terms here, and there's always two terms in the product rule because there's a plus. Clean those up by combining everything you can and putting the constant terms out in front, the x's or the algebraic parts second, and the trig parts last. So the first term didn't really change, but for this term, I'm going to write it as 1/3, that's the constant part, x to the negative 2/3, the algebraic part, times the sine of x. That's not going to be a huge deal in this problem, but it's going to make a lot of the future problems easier. So that's a good step to get into, a good habit to get into, this cleanup step. So now I'm going to figure out what do I have in common in both these terms, and I'm going to factor it out. So first of all, whenever you have a constant term, a constant multiple term that has a fraction, you always want to multiply out the fraction, or you'll get a complex fraction. So I'm going to factor out 1/3. So I can just put that right on the 8. That's my constant term. And then the variable term, you pick the x with the lower of the two exponents. That would be x to the negative 2/3. And now you're just going to write what's left in each of these two terms after you factored out this. So first of all, we'll think about factoring out 1/3 from this. This doesn't have any number here other than 1. So to figure out what's left over, you divide the 1/3, or in other words, multiply by 3. So that would be 3. 3 times 1 is 3. We factor out an x to the negative 2/3. So to figure out what's left with this exponent, we have to subtract the negative 2/3 from it, or add a positive 2/3. 1/3 plus 2/3 is 1. So it's x to the first. So that's what's left over for the first term. The next term is a lot easier because it had the 1/3 that we factored out, and it had the exact x to the negative 2/3 that we factored out. So those are both gone, and we're left with a sign. So now we're going to just rewrite it, simplify it, get rid of the negative exponent. These are both factors, so you can move things around pretty freely. This 8 will stay up on top. And the 3 can stay on the bottom. And the x to the negative 2/3 is x to the positive 2/3 when we move it down to the bottom of the fraction. And that's the derivative. That takes some getting used to, especially that factoring part. So if you need to watch the video again, do so, and then practice. Number 2 is going to be a quotient rule. So I don't see any constant multiple I can factor out, so I'm just going to go straight with a quotient rule, which is the bottom times the derivative of the top, which would be 2, minus the top times the derivative of the bottom, which is 4x cubed, all over the bottom squared, like that. Now, at this point, I would go over my derivative quickly just to make sure I didn't miss anything. A lot of times people forget to write this cubed and other dumb mistakes. I mean, there's always dumb mistakes that happen here. You want to catch that right away before you start simplifying. Because obviously, if this isn't right, all the simplification is not going to be correct. So I think I'm good. My next step is to clean up just like I did over here, which means in this case, I'm going to put the constant terms like this in front of the binomials. I always do that. It's a good habit to get into, and it will help me to decide what to do next. The next step, I can decide to factor if I had a obvious common factor up here, or I could multiply out and combine. I could factor out a 2. That is a common factor, but I don't think that's worthwhile. I think it'd just be easier to multiply out and combine. And by the way, this is bad notation. As soon as you take the derivative, make sure you label as the derivative. So now I'm going to multiply out. Distribute this 2x to the 4th plus 4. Distribute this negative 4x cubed. So we have minus 8x to the 4th plus 28x cubed. And I'm never touching the bottom because that's already nicely factored for us. Combine like terms. 2x to the 4th minus ax to the 4th is negative 6x to the 4th plus 28x cubed plus 4 all over the bottom squared. Now that I have it all multiplied out, I'm going to check to see if I can factor anything here. And they do have a common factor of 2, which isn't surprising because up here, we noticed that they had a common factor of 2. That won't disappear. So basically, I just put off doing that until right here. And as a matter of fact, I'm going to factor out negative 2 because usually we like to make the leading coefficient up here positive. So factor out negative 2 from the top. That would give us 3x to the 4th minus 14x cubed minus 2 all over x to the 4th plus 2 quantity squared. Looks like I made this a 3 for somehow. That's square. That's completely factored. Now, I'm going to quickly check this on Wolfram Alpha, as you probably should as well. Don't worry, I have it all pre-entered. So I entered differentiate 2x minus 7 over x to the 4th plus 2. The first thing you do when you hit that equal sign is make sure that you typed it in correctly. So this should look like exactly like the original problem. And then look at the answer. The answer looks a lot like my unsimplified form. Usually Wolfram Alpha will simplify it, and usually down here we'll see an alternate form, which you do right here. Whoa. I clicked on that and it All right, here it is. And that looks exactly like my answer down here. So we're good. That's going to take some practice. So make sure you do practice it. I'm going to share one more after this, just another quotient rule, but we'll do that in a separate video because this is getting too long.